Detection of elements, Lessaign's test. Preparation of Lessaign's extract. We require a china dish, organic compound, funnel, tripod stand, wire gauze, distilled water, Bunsen burner, fusion tubes, test tube, sodium metal, small spatula and forceps. Take a small piece of sodium metal using the forceps. Place the sodium metal piece on the filter paper and dry it by pressing it with another filter paper. Take dry sodium using the forceps. Hold a fusion tube using a tongs and put the dry sodium in it. Heat the fusion tube slightly over the Bunsen burner so that the sodium melts to a shining globule. Take a pinch of organic compound using the spatula. Add the organic compound into the fusion tube. Replace the spatula. Heat the fusion tube over the Bunsen burner till it becomes red hot. Plunge the red hot tube into the china dish containing distilled water. The tube will break. Crush the tube with a glass rod. Repeat these processes 2 to 3 times and heat the contents of the china dish to boiling point for a few minutes. Stop heating when the volume of the liquid in the china dish is reduced to 1/3 of its initial volume. Take a filter paper. Place the filter paper in the funnel, which is fixed to a stand, and filter the contents of the china dish through the funnel to a clean test tube placed under the funnel. The filtrate is called Lessaign's extract. Detection of nitrogen. We require freshly prepared ferrous sulfate solution, ferric chloride solution, concentrated hydrochloric acid, test tube, Lessaign's extract, and droppers. Take a small amount of Lessaign's extract using a dropper and pour it into a clean test tube. Using another dropper, take a small amount of freshly prepared ferrous sulfate solution. Pour ferrous sulfate solution into the test tube containing Lessaign's extract and hold the test tube with the test tube holder. Heat the test tube over the Bunsen burner. The sodium cyanide formed during the preparation of Lessaign's extracts is converted to sodium ferrocyanide. On treating with ferrous sulfate, place the test tube in the test tube rack. Take a small amount of ferric chloride solution using another dropper. Add ferric chloride solution into the contents of the test tube. Using another dropper, take a small amount of concentrated hydrochloric acid. Add concentrated hydrochloric acid into the contents of the test tube. On further treating with ferric chloride and concentrated hydrochloric acid, sodium ferrocyanide forms a Prussian blue complex, ferric ferrocyanide. Detection of sulfur. Sodium nitroprusside test. We require sodium nitroprusside solution, test tube, Lessaign's extract, and droppers. Take a small amount of Lessaign's extract using a dropper and pour it into a clean test tube. Using another dropper, take a small amount of sodium nitroprusside solution. Add a few drops of sodium nitroprusside solution into the test tube containing Lessaign's extract. The sodium sulfide formed during the preparation of Lessaign's extract gives a purple or violet color with sodium nitroprusside due to the formation of sodium thionitroprusside. Lead acetate test. We require acetic acid, lead acetate solution, test tube, Lessaign's extract and droppers. Take a small amount of Lessaign's extract using a dropper and pour it into a clean test tube. Using another dropper, take a small quantity of acetic acid. Add acetic acid into the test tube containing Lessaign's extract. Take a small amount of lead acetate solution using another dropper. Add a few drops of lead acetate solution into the contents of the test tube. Sodium sulfide formed during the preparation of Lessaign's extract reacts with lead acetate and forms a black precipitate of lead sulfide. Detection of halogens. Silver nitrate test. We require concentrated nitric acid, silver nitrate solution, ammonium hydroxide solution, test tube, Lessaign's extract, droppers. Take a small amount of Lessaign's extract using a dropper and pour it into a clean test tube. Using another dropper, take a small amount of concentrated nitric acid. Hold the test tube using a test tube holder and add concentrated nitric acid into the Lessaign's extract. Boil the content of the test tube over the Bunsen burner for some time. Cool the contents of the test tube. Take a small amount of silver nitrate solution using another dropper. Add silver nitrate into the contents of the test tube. If the organic compound contains chlorine, the sodium chloride formed during the preparation of Lessaign's extract reacts with the silver nitrate and forms a white precipitate of silver chloride. If the organic compound contains bromine, the sodium bromide formed during the preparation of Lessaign's extract reacts with silver nitrate to form pale yellow precipitate of silver bromide. If the organic compound contains iodine, the sodium iodide formed during the preparation of Lessaign's extract reacts with silver nitrate to form yellow precipitate of silver iodide. Take ammonium hydroxide solution using another dropper. Take the test tube containing white precipitate of silver chloride. Add excess of ammonium hydroxide into the silver chloride precipitate and shake the test tube well. Silver chloride is soluble in excess of ammonium hydroxide due to the formation of a soluble silver complex. Take ammonium hydroxide solution using the dropper. Take the test tube containing pale yellow precipitate of silver bromide. Add excess of ammonium hydroxide into the silver bromide precipitate and shake the test tube well. Silver bromide is sparingly soluble in excess of ammonium hydroxide. Again, take ammonium hydroxide using the dropper. Take the test tube containing yellow precipitate of silver iodide. Add excess of ammonium hydroxide into the silver iodide precipitate and shake the test tube well. Silver iodide is insoluble in ammonium hydroxide solution. Carbon disulfide test. We require chlorine water, carbon disulfide, dilute hydrochloric acid, test tube, Lessaign's extract, and droppers. Take a small amount of Lessaign's extract using a dropper and pour it into a clean test tube. Use another dropper. Take a small amount of dilute hydrochloric acid. Add dilute hydrochloric acid into the test tube containing Lessaign's extract. Take a small amount of carbon disulfide using another dropper. Add carbon disulfide to the test tube. Carbon disulfide forms a separate layer above the Lessaign's extract. Take chlorine water using another dropper. Take the test tube containing Lessaign's extract. Pour chlorine water to the test tube and shake it well. When sodium bromide formed in the Lessaign's extract is treated with chlorine water, the bromide is oxidized to bromine. Bromine dissolves in carbon disulfide and imparts an orange color in carbon disulfide layer. When sodium iodide formed in the Lessaign's extract is treated with chlorine water, the iodide is oxidized to iodine. Iodine dissolves in carbon disulfide and imparts a violet color in the carbon disulfide layer.